Hello, in this video I'm going to go through some of the exercise questions for lesson 3.1, starting with the first 5 questions. This is where we name fractions. So when we see 1 over 4, this has 2 names. We can call it 1/4, or we can call this 1/4. Some fractions have more than one way to name, and when you have a denominator of 4, you can use the word quarter instead of fourth. Think of it in terms of 1/4, like 25 cents. You'd have 4 of those to make $1. That might help. So 1/4 or 1/4 means 1 of 4 equal parts. Number 2, we have 1 over 3, which is called 1/3. Notice that I'm using ordinal numbers for the denominator. Ordinal numbers mean the kind of numbers we say when we show places, so first place, second place, third place, and so on. It means 1 of 3 equal parts, 1/3. Number 3, we have 1 over 6, so this is called 1/6. Using TH, it means 1 of 6 equal parts. For number 4, our denominator is 4, but our numerator is 3, so we have 3/4. And here we'll use an S because we have 3, not just 1. Or we can call this 3/4. It means 3 of 4 equal parts. And number 5, we have 2 over 3. This is 2/3 with an S. It means 2 of 3 equal parts. Moving ahead to question number 6, what part of the whole is shaded? So what we look for is the part that is shaded and the total. So for A, we can see one part is shaded and we have 1, 2, 3, 4, 5. We have 1 of 5 equal parts. This can be expressed as a fraction 1/5. For B, we also have one figure shaded, and we have 4, 5, 6, 7, 8 equal parts. This fraction could be expressed as 1/8. For C, we have 1 shaded out of 6 equal parts, 1/6. And for D, we have 6 of the figures shaded out of 8. So this fraction can be called 6/8. One thing you can notice about 6 over 8 is that this fraction actually can be expressed in a different way. And it's something that we'll get to a little bit later on in our lessons. But if you cut this in half and you looked at it in terms of what you had at the top row and what you had at the bottom row, you would see in the top row you have 3 out of 4, and the bottom row you have 3 out of 4. So 6 out of 8 is also equal to 3 over 4. Now you don't need to have that answer for D, but it's something to show you. And another way to look at this is, can I divide the numerator and the denominator by the same number to get a different fraction, but a fraction that is equal to this? And I can divide 6 divided by 2 and 8 divided by 2, and I get to 3 over 4. So these two fractions are called equivalent fractions. We have 6 out of 8 of the pieces shaded, but that also is equal to 3 out of 4. For number 9, you're going to use a pencil and maybe a ruler or maybe the side of a book, or just do your best to divide the figures evenly. You're going to divide them into even parts based on the denominator. Remember that the denominator is the total number of pieces, and the numerator is going to be the number of pieces that we shade. It doesn't matter how you divide the figures up as long as the figures are fairly evenly divided. So for example, I can divide it into 2 equal parts by drawing a line this way, or I could draw a line vertically. Both of these answers would be acceptable. But what I'm going to do is shade the figure to represent 1/2. So one side is going to be shaded. so that we show one side out of the 2 in total, 1/2. For B, I'm going to divide this figure into 8 pieces. This is not always easy, especially without a ruler, but we do our best. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I just do my best to try to get that fairly divided. And I'm going to shade 7 out of the 8 figures. So out of the 8 pieces, 7 of them are going to be shaded. For 2/3, I divide this figure into 3 pieces, and 2 of them are shaded, and this represents 2/3 or 2/3. For D, 3/5, and again, it doesn't matter which way you want to divide this, as long as you're dividing into fairly equal pieces and you have 5 of them, and you shade 3 of them. And for E, we have a fraction that shows the denominator and the numerator being equal to one another. We're going to divide this figure into 4 equal parts, and we're going to shade all 4 of them. And then we're going to notice something very important with fractions, that when the denominator and the numerator are the same, this means that the entire thing has been taken up. The entire figure has been shaded. So 4/4 is equal to 1. Just like if you were to take a test and you were to get 4 out of 4, that would be 100%. So when the numerator and denominator are the same, then we see a fraction that is equal to 1. The rest of these fractions are all less than 1. Number 10 is an interesting question. What we have is we have 3 pizzas here, but we have 4 students that are going to equally share these pizzas. One thing we need to notice with fractions is our denominator is expressing what we're dividing a single figure into. So when we see this first pizza and all the other pizzas, we see that they are all divided into 4 pieces. That's really important because we don't want to count the number of pieces in total. We want to keep it into what is a single item being divided into, and it's divided into 4ths. Now let's start to divide out this pizza amongst our friends. So let's say that person number 1 gets a piece, then person number 2, then person number 3, and person number 4. So now they've eaten that first pizza. And we're going to go ahead and eat the second pizza. First person, the second person, the third person, and the 4th person. And we're going to do it again for the 3rd pizza. Everybody's getting 1 piece. So what fraction does each student get? Well, person number 1 gets 3 pieces. And so does person number 2. And so does person number 3. And so does person number 4. Everybody gets 3 pieces. But the fraction value is out of 4 because a single pizza is divided into 4 pieces. So the fraction we're going to get here is 3 out of 4. There's another way we can look at number 10 as well. And that's the fact that we have 12 pieces of pizza here. So if we have 4 students equally sharing these 3 pizzas, and we can see that in total we have 12 pieces, we can say, well, okay, 12 pieces in total divided by 4 people means that everybody's going to get 3 pieces. So if everyone's going to get 3 pieces, that means that the person in blue is going to get 3. I'm going to change my color. And this person that is yellow is going to get 3 pieces. And this person that is green is going to get 3 pieces. And the person that is red is going to get 3 pieces. And if we took those red pieces and we put them together, we would see that we could create, I guess, kind of a missing, another pizza with a missing piece. So everybody's going to get 3 pieces out of a total of 4 in their pizza. So this is again why we can say that this fraction is represented as 3 over 4. Number 11, we're to draw a square. So we do our best to get it kind of looking like a square. And we divide it in half. So we're going to divide it in half. What fraction is each part? Well, we've divided into 2, and so we will have 1 out of 2 for each of those parts. For B, it's asking us to divide each of those parts in half. So we're going to divide this in half and this one in half. What fraction is each part now? Well, now we have 4 total pieces, and each piece will be 1 out of the 4. Now we're to divide each of these parts in half. So I'm going to divide that part in half, and that part in half, and that part in half, and that part in half. And now we can see that we have a total of 8 pieces, and each part is 1 out of 8, or 1/8. And again, we're going to divide each part in half. So this one in half, and this one, this one, this one, this one, this one, this one, and this one. So how many pieces do we have now? We have 16. And each part is 1 over 16. So as the pieces are getting smaller, what's happening to the denominator? The denominator is getting bigger. And why is that happening? It's happening because we're increasing. So I'll write because we are increasing the number of pieces when we divide. So as we divide this figure into half, into quarters, into eighths, into sixteenths, our pieces are getting smaller and smaller and smaller, and we're getting more and more of them. And what's happening is our fractional part is also getting smaller. So 1/2 is greater than 1/4, is greater than 1/8, is greater than 1/16. And if you remember back to the beginning, when we divided that figure into half, we can clearly see that 1/2, one of these pieces, is far bigger than 1/16. So we can see that the denominator, even though the number is getting larger, the pieces are getting smaller, and therefore the fraction is also representing a smaller and smaller number. Number 12, Tony received 12 CDs in the mail. He sent 4 of the CDs back. Ooh, this is a little bit old question now, hey? What fraction of the CDs did he keep? Okay, so he got a total of 12, and he sent 4 of them back. So what fraction did he keep? Okay, well, the total is going to be 12. That won't change. That's how many he got. That's our maximum, our denominator. He sent 4 of them back. So he took 12 minus 4. He took 4 of them away and sent them off. So that leaves us 8. So that means that 8 of them is what he kept. So the fraction that he kept is 8/12. The textbook shows a second answer that is possible, and that is an answer that is equivalent but reduced, because if we wanted to, we could divide both of these numbers by 4, giving us 2/3, which is another possible answer because 2/3 is equal to 8/12.